stands for Vesta Exploratory Surface Topography Asteroid Lander. And today I'm joined by Sarah, our engineering lead, Nikita, our logistics lead, and Patrick, our science lead. And we're going to be talking in a little bit more detail about our mission. So the Vesta Exploratory Surface Topography Asteroid Lander, as you can see on the right, is tasked with investigating the asteroid Vesta in order to get a better comprehension of its computational pressure. Water presence, I'm sorry.
I am Patrick, science lead. We chose 3 landing areas, 3 craters. One, the crater Runtia, the crater Octavia, and the crater Ilia. They are separated by kilometers, so they meet the minimum distance of 150 meters apart. They're all flat, or relatively flat, and they lie in a hydrogen-rich area. And this will help to fulfill one of our science goals. We'll have 3 goals. First, we will be looking for oxygen, water, and other biological materials. And we will also video record the surface. In order to do that, we will use the 2 devices pictured here on the screen. The one on the left is the Ultra Compact Imaging Spectrometer, also known as UCIS. And the one on the right is the Scanning Habitable Environments with Raman and Luminescence for Organics and Chemicals, also known as SHERLOC. They both contain a spectrometer and a video camera. UCIS will primarily work as the spectrometer, while SHERLOC primarily acts as the video camera. And in case one goes out, the other one will be able to take its place. A spectrometer works by capturing light, either emitting from or reflecting off of an object. And it will break that light up into its respective wavelengths. Not all wavelengths will come through. Scientists would be able to take the images that do come through and match them up with the spectrographs of known elements, like the ones listed at the top of the page, and thereby determining what elements make up that substance. Thank you.
All right, my name is Sarah. I served as the engineering team lead for this mission. So for this design, we chose a somewhat simple design that has to fit within a 50 by 50 by 50 centimeter cube, essentially. So for this mission, our lander weighs overall 14.3 kilograms. And it is composed of 5 major main systems: UCIS, a battery module, SHERLOC, an electronics module, as well as our hull thruster. The 2 payloads are UCIS and SHERLOC, as Patrick mentioned earlier. So the main propulsion element for our lander is the hull thruster. It's a form of solar electric propulsion that is, the power is derived from the solar arrays that we have. We have 2 of those, and those are inspired from the Mars InSight mission. So the energy used from the solar arrays will be used to power the lander itself, as well as the propulsion component. We do have a battery pack that any extra energy that we have will be stored so that the rest of the lander can be powered from either the battery or the solar arrays.
So our is basically our mission is gonna serve as a secondary payload and a launch from Earth, and our lander is gonna be going on the Vesta transfer as seen on the screen. Once arriving at the asteroid, we're gonna be released into the asteroid and perform a landing. that all the scientific experiments are going to start taking place. And once we have touched the asteroid, the orbiter is going to be going around the asteroid. All the communication is maintained between the lander and the orbiter. That will ensure that the data collected is sent to the orbiter and then sent back to Earth, where our scientists can further analyze the data.
Hi, my name is Nikita, and this is the milestone schedule for our team. So it starts with the project start in September and outlines several reviews throughout several years leading up to the launch in 2022. We have the system readiness review, which is meant to be a formal review of the system requirements between the agency and the contractor. Preliminary design review, which is a technical system assessment of a system to ensure it meets qualifications per the standards of the government agency. Critical design review, a multidisciplinary review to ensure a system can proceed to manufacture. Test readiness review conducted to determine if the system is ready to be formally tested and to ensure it is in compliance with test procedures. And finally, mission readiness review, which is a pre-flight assessment of the readiness of the system, hardware, software, support equipment, and other resources. And then finally, the launch.
This is a little bit about our project. Thank you so much for listening. We hope you guys enjoy.